So, we are back from the break. Just some words about use cases. So, me personally, I'm currently supporting a paid POC at a major German bank for Spark. And there are some use cases, but it's currently adopting. So it's not that it's present in each and every enterprise or startup. Here are some ideas on use cases. So customer churn reduction. So you can do machine learning for predicting the churn probability of a customer based on different features. And the cool thing, since you are here in the big data space, there is nearly no limit on data sources. There's no limit on the number of features. So you can maybe do better predictions because you have more features to consider, even external data sources. Cybersecurity, I've worked in such use case also, but not on Spark. It was on InfoSphere Streams for real-time network surveillance. So in Swiss banks, you have the problem that there's a data leakage and people try to sell CDs of customer data to the German tax institution, and the system was able to detect this. This might also be possible with ApacheSpark. Here's some network performance optimization, customer behavior analytics, and predictive maintenance. So you can, for example, use MQTT connectors to get data from a lot of devices and process that using the MLlib machine learning library, which I will introduce later as well. And if somebody here in the room has a comment on a use case he wants to share, please go ahead. We can also discuss this. You have time for that. Okay. Otherwise, I just tell you about one productive use case which IBM and the NASA are doing together with Penn State University. So it's actually IBM research. So there is in North California, there's a radio telescope, and this is constantly generating data. And this data is then at the moment stored in IBM SoftLayer, which is the infrastructure cloud branch of the IBM cloud, the SoftLayer object storage. The reason for that is we've discussed that in the break. It's pretty cheap, so it's around 3 to 4 cents per GB, and you never achieve such cheap prices if you're doing it on traditional storage. And the data remains on the SoftLayer object store and is then processed using this pipeline here. So this at the moment is the picture as it should be in future, because they are currently migrating from a complete infrastructure as a service installation and deployment with object storage and Spark to Bluemix, and they will be the first commercial productive client using this platform. The cool thing is all they are doing, they are sharing it on GitHub. So you can see what they are doing. About the data, I'm not sure, at least the code. They are doing it all in Python. And here you see the IPython Jupyter notebooks, which we are also using here during the exercise sessions, and some graphs which they plot. We will also learn how to plot graphs during this session. And the researchers, so these are radio astronomers and mathematicians, they are currently learning Python, and they are coming from MATLAB. And it's not so a big step, but it's a step for them to learn. But they've taken the challenge, and they are quite happy now doing the same stuff which they've been doing with MATLAB on a small scale with small data. They can do it in these notebooks, and everything is just parallelized, and they have no limits anymore, at least from a technical perspective on data size and performance. So now we are completely diving into the second lab. So it's Twitter sentiment analytics. and you can access it on this short link. It's IBM Velocity 2, or you can use the link on the first tutorial. At the bottom there's also a link to this tutorial. And again, for those who don't want to do it, I will walk you through on my laptop. And for those who are doing it, if you have any questions, just ask and I will try to answer them in parallel. After that, I have a little demo, and after that I have the final challenge for you, how to draw insights from Apache HTTP server log. And using the information you get from this lab and the previous introduction to Scala and functional programming, you should be able to solve it. It's like 6 to 7 lines of Scala or Python code, and of course I'm here to help you. But as I promised, at the end of the 2 sessions, I want everybody who is interested to be able to write functional programs in Scala and or Python using this cloud service. So I think that's achievable. So I will also click on this link to see what you can expect. So if you're really lazy, you can just lay back and watch this video. But in my opinion, you won't get too much out of it. So what the application does, basically, it uses a couple of technologies. One is Spark streaming. So I've been asked about Spark streaming in the break. We will see how that works. We will see how the Twitter connector is working. Then another cool thing is we will see how to call a REST service out of this computation and enrich our data. So the Watson tone analyzer is something like a sentiment analyzer. You send text there and you get back a sentiment score. The thing is, this service is in experimental status at the moment, and yesterday it returned 0 values only. So we will check this today if this is better. If not, you will see a lot of zeros, and therefore the graphs are not looking so fancy. But that's the drawback of using experimental services. So we will do this capturing of tweets and data enrichment, preprocessing, and later we will use a second notebook for plotting the graphics. And here you can see the first one is written in Scala and the second one is written in Python, so you will easily catch up both programming languages. And don't be scared, the syntax, at least for Spark, is really similar. The only difference between Python and Scala is the syntax for the lambda notation, which is the creation of an inline function, but I will show that to you later. You can skip this part if you like. That's basically just copying all the data to your machine and creating one single self-contained jar. But in my opinion, there's not so much to learn out of this exercise. You can use the sample jar which is provided. Here's the link for that. And for those of you who really want to do it, you have to do 2 things. You need credentials on Twitter, because you will use the Twitter REST API in order to get the tweets, and that can be done with your Twitter ID. So you need a Twitter ID for that, and you go to dev.twitter.com, and it will take you, if I don't tell you, 2 hours to find the link. So you have to go to manage your apps. And there you can just create an app. And an app means it's an app running somewhere using the Twitter API. So you have to just make something up. So create a new app. And what you need is, you need a consumer key and a consumer secret. So I'm recording this, but there's no issue if somebody copies these values, because I've not given write permissions to this application, so there's no problem with that. And you can have to generate the access token. So you need these 4 values: the consumer key, consumer secret, access token, and the access token secret. And this you have to paste somewhere later. So that's the first step. For those of you doing it, that's something you have to do. And for the rest, I will do it now. And the second thing is you need the same credentials for this Watson Tone Analyzer service. And for that Watson Tone Analyzer service, in order to obtain the credentials like you got here, the most easy thing is to create an empty application and bind the tone analyzer against it. So I will just do that now. If you don't really understand what's happening there, that's okay, because you need some Cloud Foundry skills to understand what's happening here. And that takes 2 to 3 hours itself. So I will just create an application, and when I have an application, I can bind the service to the application. And once the service is bound to the application, I can obtain the credentials. That's the thing I have to do. So I will wait until this is staged. And as I have done this before, I can just carry on here, because I have already copied the credentials. So let's go back to the tutorial. So what it basically says is, it's this one. I will increase the size a bit. So I have to obtain these credentials from Twitter. I have to create a Spark service, but that you have already done. And then you have to create this tone analyzer. And then you have to obtain URL, that's the URL endpoint of the REST service, the username and the password. And that I will show you later once this application is staged. It's already staged. So I will now go to this application, and as I said, I will add a service to this application, and this service is Watson service. So I set the filter to Watson here. And it's an experimental service, so I go to Bluemix lab catalog. And I say tone analyzer. And I say create. Then it asks me to restage the application. That's part of the Cloud Foundry deployment lifecycle. So I don't cover the details here, but just click on restage. And once it is restaged, you can get the credentials. Now you see here URL, that's the REST API endpoint, username and password. And basically this is now HTTP basic authentication. And just to see how it works, I have just prepared this here. So that's hurl.it. It's a web application allowing you to issue HTTP requests to some URL. And that I'm using to test this REST service. So it's post method. That's the endpoint of the Watson Tone Analyzer. That's the username and the password using HTTP basic authentication. And it expects, of course, these headers here, so JSON, blah, blah, blah. But it expects the text to be sent to it as the content of the post HTTP request in a JSON format. So text, and hi, this is a very positive text because I'm happy. And yesterday it was returning zeros. So let's check if that is fixed or not. Now it's returning null values again. So you will not see very interesting graphs, but it will run through. So you will get the point about Spark streaming, Spark SQL, and all that stuff anyways. But that's just the introduction how the the Watson tone analyzer service is integrated. So that's on this diagram, it's this part here. Okay? And once we have the credentials and we have the Spark notebooks, so what we do here is, as in the previous example, we are using the already finished application, but I will walk you through the code a bit later that you get an idea about Spark SQL, which is Shark, and that you get an idea about calling a REST service out of a Spark application, and the third thing is Spark streaming, so that you have at least have seen some Scala code on top of that. But this is the application, so if you download the jar, it will be added to the class path. So that means this line here will execute successfully. That's the class inside this jar. And that's also a thing of Scala. You can just create a short handle of objects, because this class is just a class object where you can assign it to a demo, and then you can use this shorthand notation. And here you have to set some environment variables for the Twitter, so these 4 keys, and for the Watson, the URL, username, and password. Once you have done that, you can start this application, and I will show you what is going on inside the code later, but it basically will call the Twitter API for 30 seconds and just grab tweets. And the Twitter API, which is for free, doesn't return you all tweets. It's only around 10%, and there's a rate limit. So if you want to have all tweets going on in the world, you can either directly go to Twitter, Firehose it is called, or there's also in IBM Bluemix a Twitter Insight service. And the cool thing about that, so IBM and Twitter have a partnership. You get all tweets which are going on in the world. And IBM stores it for 1 year, so you can also go into the past and do really cool analytics, and you get some demographic information which you don't get on the public URL. But this demo is using the public Twitter REST API. So what happens here is we are creating a so-called SQL context, and within that a data frame, and on the data frame we can then issue SQL commands. And that's pretty cool for those not familiar with Scala or Python and functional programming. They can just use their SQL skills, and I will just show you how that works. So I will go to my prepared code, which is here. So what I do here is, it's the same code like in the tutorial, but I've set all that credentials, and I will run it now in a notebook, in a Scala notebook. So let's close this one. So I say here close and halt, so the kernel will be stopped, and I will create a new Scala notebook. And what I have to do is the same what is written here. First, I have to obtain the jar file and add it to the class path, which is here. -f actually means that you always load the file even if it's in the cache. So in case you are changing it, it gets picked up. So I will execute this. I will increase the size a bit for you. So now we have it in the class path. That means we can run this code here. Let's try if that works. Okay. And now we just set the complete config. So we have set the config. And now what we do is we import all the Spark streaming classes which are necessary for that application, and then we just grab tweets for 30 seconds. So we can just wait and so this application actually is starting a thread and returns immediately. So you can either wait 30 seconds and use it, or you can stop it. So there's an example how to stop it, but I won't do it. Just that you're aware of it. It's here. So you can say stop Twitter streaming. And as I said, I will walk you through the code later, so you will see what's going on there. So what we can do now is we can create an SQL context, and then you can just do plain SQL in Spark. So let's do that here. So it prints the schema. The schema is created in the application, so it's not coming from nowhere. It's a manual thing which the author did. And you see here, these are some tweets. And now I can use this SQL context to issue plain SQL commands. So select, for example, count, star from tweets. So it's 265 in 30 seconds. What else? Select star, maybe, to see what's all in there. And now you see here the problem is that all these numbers are 0 because this Watson tone analyzer service is experimental and currently doesn't return real values. Otherwise, it would be a bit more interesting because then you could group and query and aggregate on that stuff. But no worries, you will get the idea anyways. So we will just continue in that tutorial. So what we now create is a full set, and this full set we will store to a Parquet file in the object storage. And Parquet is a file format in the Hadoop ecosystem which is very performant. So it's not a text file, it's a compressed binary format. And Spark is capable of reading and writing to Parquet as well, so we will use Parquet. So first of all, we will execute this command here. So all that stuff is now kept in the full set variable. And this full set we will now store to a Parquet file. And we will store it on the Swift service. So you could use Amazon S3 here, but we are IBM and OpenStack and so on, so we use Swift. So what we do here is we do a repartitioning. That means we just concatenate all chunks of the file into one, and we save it as Parquet file, and the URL is just the URL on the Swift storage. So we will. Yeah?
The repartition aggregates the whole chunks of file.
Yeah.
Right? And what is the Swift storage?
The Swift storage is the open source, open standard equivalent to Amazon S3. It's object storage, which is a service here in Bluemix. And remember, once you created this boilerplate, there have been one application.
I just didn't remember the name.
Okay, sorry. Okay, good. So now we will just store it to Swift. And now we will start the analysis using Python. So we will also grab some insights into Python now. So this we can ignore. It worked anyway. So it's also written here. So now we we cannot execute this query because we have zeros everywhere. So I will skip that. So now we will do the same, but so we will create a Python notebook. So we are not doing the same, but we will do an analysis using Python. So I save that to like Twitter Scala, and so yes. You should be able to do it. Otherwise, we can fix it after the session at 5:30.
Can't find the tone service.
The what service?
The
Did-
Watson tone service.
Are you in US or in UK?
I switched to the US.
Okay. Have you clicked on the experimental catalog?
Couldn't find an experimental.
Okay, so you go to. Just give me 1 second. I will just help him. It's just fast. So you go to Services Watson, then you go to Bluemix Labs catalog, and then it's there. Yeah, we hide it because we don't want that somebody accidentally uses. So save, and then close and hold. So in case we need it again. So now I create, in contrast, before Scala, I create a Python notebook. It's Python 2. So I'm not a Python guy, but there seems to be Python 1, 2, and 3, and I don't know which one to use. That's Python 2. And I will. So I have to import Python classes now, and basically Python and Spark, they work together with wrappers. So basically Python in the background uses things already there for Java and Scala, but is wrapping all that stuff that you can use it in Python. So what we do here is we load the Parquet file again, and then we will create a virtual table out of this file. And then we just do that here. So, and we run it. So this worked. And the thing is, if you're using Python and Spark, you will get some weird exceptions on errors, because first of all, you will see a Python exception, and then you will see the wrapped Java or Scala exception. But and most likely you will find, if it's not a syntax error, you will find the solution to your problem in the Java or Scala exception. So we have created this virtual table now. Now it's time to do some analytics. So that's just some data preparation. And then, so we're using this plot library, and this plot library will show you then sentiment distribution, but it's not so funny to calculate the sentiment distribution on 0 values. But the cool thing is, David, who has written this tutorial, has put a screenshot there, so you get a little of an idea how it looks like. But you see here the interesting thing about the integration. So that's a Python library for plotting charts, and this is integrated in the Jupyter notebook, that actually the chart will get sent back to your web application and is displayed here inline. So that actually puts you in the position to do anything in that notebook. You can write your documentation using markup language. You can write your code in Scala and Python, and you can see the results all in one document, and you can print it and share it, and so that's the basic idea about all this. So let's continue a bit. So now it gets really complicated, so I won't dive into that, but just a few words. So we had map, and flat map is nothing else than a map which is capable of processing lists as a result. So each function call on each element will create a list as result, and then the map is flattened. That means if you are using map, you will get an array of arrays, and if you are using flat map, it will flatten down to one single array, merging all the contents of all lists. So here you see the notations for creating a lambda function in Python, which then is being transformed into a closure and sent to the Spark workers. Here starts with a hash, so it actually seems that it tries to find hashtags. And that's the typical thing if you do word counts. You emit a tuple. First is the key, and the second is 1. That's the basic standard Hello World word count example, even in MapReduce times. And then it's reduced by key. That means it will execute a function on all data belonging to the same key. And the function here is add. So you see here, we even don't implement it, we just import the add function, and as we are in the functional programming paradigm, we can just pass this function as a parameter to the reduce by key function. We do some sorting and blah blah blah, and then we just take the 10 most frequent tweets, the 10 most frequent hashtags. I think that could work. We have to check whether the amount of data is sufficient, because we have only something like 300 tweets. So this take 10 just returned us an array or list, and now we can use that to plot. Let's see what happens in this case. So we are plotting a pie chart. So that's PLT is the Python plotting library, and then .py means pie chart, and you can .bar is bar chart, and .scatter is scatter plot, and so on. You see here it's working. So because we are not using the Watson tone analyzer for this part, so you see here this is the distribution of hashtags for that particular 30-second sample of tweets. Let's continue. Okay, now the thing is, we are doing this same thing but based on the sentiment scores. Of course, this doesn't make sense without sentiment scores, but just to show you that basically the function works, I just paste it anyways. So this, I think, is still running because it's quite a heavy computation. Yeah, so we have to wait until the star disappears. So now it's done, and now we can plot. And as I expect, the results are not so nice because the scores are missing, but anyways, it works. You see here, that's the plot bar chart function and so on. And you can use this later for the challenge. So at the end of this session, there's a challenge where you can implement something, and you have to, you really want to finish it, you have to use that plot library. So you see here all the bars are flat, but in his example here you see the bars are like that. So as promised, I will walk you through now through the Scala code for this application actually gathering the tweets, and then we will go to the next thing. So streaming. So okay, so it's a lot of code, so I will only show you the most important parts regarding streaming and regarding the SQL context. So this is the start Twitter streaming method, which we actually call from the Scala Jupyter notebook. And the interesting thing starts here, so where we obtain a streaming context out of a Spark context. So the Spark context is something you always have available. Without Spark context, you cannot work because you need a Spark context in order to create a RDD. And for creating a stream, you need a Spark context as well. And you have here the streaming context. And the same holds for the SQL context. So you can create the SQL context out of the Spark context. And using the SQL context, you can create data frames, which you then can use to query against files using SQL. So that's some Scala magic in order to create the schema declaration. Scala is very like Spark, strong at data structures and lists and so on. So the first one here is a list for the schema for the tweets. And the second one is a list for the schema for the output of the Watson tone analyzer, and the union function just unions the two lists. So that's the normal mathematical set operation. So and then we do some filtering on the metadata on the tweets, but the thing is the stream actually will capture us the tweets using the Twitter API. So that's the Twitter thing, and now here starts the call to the REST service, and there is a HTTP client available for Scala, which is used to call the REST service, and this is done here. So call tone analyzer. So we have to check for the call tone analyzer method first. This is this one. So we pass the HTTP client, the URL, password, and username, and the request actually happens here. And is done here. No? So the basic authentication tokens are passed to the request. The header, that's the same thing which I'm doing here. So that's just the normal HTTP post call. And then what I do is I check whether I get status code 200, which means everything was fine, or if I get an error. And actually I am getting back status code 200, but all the sentiment scores are 0. So that's the problem. Let's continue there. So tweets, okay, yeah, basically that's all. So we have created this SQL context out of the Spark context, and we are returning that back to the caller application, and that's what we have seen before. So we have obtained that context in order to query against the tweets. Okay, so questions so far? Okay. So what I want to do now is 2 additional things. I want to give you a little demo of MLlib, which is the parallel machine learning library of ApacheSpark, and then we can go to the challenge. So what I do now is I will upload some data, and it's a demo and not a tutorial because I'm not allowed to share the data with you because it comes from a hospital. But you will see how I can do this upload now. So I will go to my dashboard. I will go and search for my Spark service which I've created, and as you can see I can create as many as I like until I exhaust the resources in my account. So this is the 4th one I've created, and it's just a mouse click away. So I have to obtain the password. And then I click on launch. And I don't click on launch here, I click on manage files, and this will take me to the web application for managing the Swift storage. So I can upload, download, and check what's in there. And as object storage should be, there's no limit on size. Just pay for each GB which you store 4 cents per month or 3 cents or something. So what I create now is a new container. So this storage systems expect something like a container. So this I call velocity 15. And in that container, I upload, so I can use this using the web application or via REST API. And since this is open source and open standard, there are also command line tools and a lot of other tools available. So this is some patient data, and there are some features. So basically, there have been patients. Some of them died, some of them didn't die. They survived. And from that patients, they have been doing PET imaging records. And out of that PET images, they have extracted some features. And in that file, basically, is the outcome, 0, 1, death or not, and a huge set of features out of the PET images. And I want to predict, based on the PET images, if the person will be dying or not. That's the basic thing to do. So in order to do that, I will now create a new so first of all, I will close this down. I say close and halt. And I create a new Scala notebook. And I will paste the code and I will explain it to you. So this is the code. Don't be scared. First of all, I have to refer.
Don't worry, we already had an art attack.
A what?
We already
Ah.
had an art attack 20 minutes ago.
Is it? Is it my fault?
We started with lambdas and
Yeah, but this is quite simple because yeah, I will show you. So it's I have to load a file, velocity.spark. That's the container. And workbook1.csv. That will load the raw data. And then I do a lot of pre-processing. But the thing is, this is basically a matrix, because the x-axis, or the y-axis of the matrix are the different patients, and the x-axis of the matrix are the different features. And all this code here until here will create this matrix for me out of the CSV file. Okay, there's some, you see that's map, so I replace some redundant characters, and I will replace some placeholders with 0, so some empty value correction. So you can either do empty value correction by interlacing, or you can just put it to 0, which I did here, and some splitting and blah blah blah. So that's pre-processing stuff, and then basically I end up with that matrix. And what you do in machine learning, so this is supervised machine learning, because you know the outcome, you know if the patient died or not, and you want to predict for new ones, but you want to assess the quality of your prediction. So what you do is you split your data set into 2 partitions. One is the training set, which you use to train. By the way, is everybody familiar with machine learning, supervised machine learning? Otherwise, I will just show 2 or 3. Yeah, I can show 2 or 3 slides on that, and then you get the basic idea. Where is that? Ah, that's in my IBM Watson presentation. So that's the basic idea. So you have the red dots. This is training data. And you have an x-axis and y-axis, and the y-axis is the outcome. Okay. And what you want to do is you want to learn from the data a model. And this model here, in this case, it is called, the algorithm is called linear regression. You will calculate the parameters in order to draw the blue line. That means if you want to predict a point, let's say 0.5, where you don't have an observation, you can calculate it using this model which you have trained, and then you get the outcome. That's the supervised learning predictive analytics thing. The thing is here, this linear regression doesn't allow you for nonlinear functions. And also, this example here is limited to one input feature and one output feature. But you can also do it on multiple input features. So that's the model for linear regression on multiple input features. You get the outcome is y. You get an offset, and then you get parameters. So beta are parameters, and x are the different observations of the feature. So this formula here is the trained model if you have alpha and all the betas. So if you get new data with all features, so the new data is x1 to x5, you can calculate y out of this model. That's the basic idea of linear regression. But as I said, this formula is limited to linear functions. And if you have something nonlinear, you can't use linear regression. So the two most popular algorithms are support vector machines and neural networks. So a neural network can learn any nonlinear multi-feature function. And that's what we are actually doing. We are using, I think, a support vector machine. But the new hype at the moment, you can maybe Google for deep learning, for the term deep learning, are neural networks. So they are really strong in image recognition and also in bioinformatics. That's the new cool stuff going on. So that's the introduction maybe, or the recap to machine learning. And now I go back to this one. So I've created a matrix. I split into two sets. The training set, which I use to train my model. And the second set is called validation set, where I can calculate the quality of my predictions. And that's what I'm doing here. Oh, by the way, I will run this during I'm talking because it will take some time. So, and that's here. Oh, I have done something wrong. Verb, book 1. Velocity 15. Okay. So, and this object or this class is coming from the Spark MLlib package. You see that here, the imports, ApacheSpark MLlib, and there are some basic classes I need, vectors and labeled point. But here this SVM with SGD is the algorithm. So SVM stands for support vector machine, which is a model like linear regression capable of modeling nonlinear multi-featured functions. And with SGD means the algorithm on how to find the parameters, because you need to find parameters to your model, like this one. And the algorithm is called, in this case, stochastic gradient descent, but I won't go into details, but that's the reason why it has this funny name. And what this returns is the SVM model. And the SVM model basically is nothing else than this function, but with the parameters, and that you can use to predict. Okay. So I do here train. So training is nothing else than my training matrix. So all the observations together with the outcome, so if the patient died or not. And then this will run, and I can here define a number of iterations. And especially Spark is very suitable because a lot of these algorithms have a huge set of parameters. And the performance on the prediction varies based on the parameters chosen. And you can do nested loops and searching through a multi-dimensional parameter space in order to run this or train this model using different parameter sets. and you can then assess the quality of the model for each parameter set. So what I'm doing, but I'm not doing this here. It's just one run with default parameters. So, and what I do here is I use the obtain model, and I predict the outcome based on the model, and that's what I'm doing here. So test is the part of the matrix which I haven't used to train the model. And what I do here is it's also a map function on each row in this matrix. I calculate the score based on the model, and I also put here the actual value. So for the test set, I'm having here score and labels RDD. For each row in the test set, I have the value what was actually the outcome and what has been predicted by my model. And then there is a very handy binary classification metric class in MLlib where I can pass such an RDD. So it expects an RDD which is a set of tuples containing the score, so the predicted value and the actual value. And who of you is familiar with ROC, area under curve? One, okay. So that's basically a method to assess the, to keep it short, to assess the quality of a prediction. 0.5 means very bad. It means just random. So my algorithm is not very good at the moment. I have to do some homework. And actually 1 means perfect prediction. And my job basically is to at the moment to increase the quality of that prediction. Okay, so any questions to MLlib? Yeah? The outcome. Yeah, so we'll show that to you. There is a helper class called labeled point, and I am creating a labeled point somewhere here. Here, I'm creating a new labeled point, and the labeled point has 2 parameters in the constructor. The first one is actually the target variable or the target outcome. So in my data, this is the array at index 1. So the first column in my raw data is the outcome, death or not death. And then the second parameter is a vector of all the remaining features or the remaining values of that row. And here I'm using some Scala magic, because you can do in Python and Scala, you can easily inline obtain subsets of lists, and I'm just passing a subset of this array to the constructor of this dense vector. So there are sparse and dense vectors and sparse and dense matrices. So if you have a sparse data with a lot of zeros, a lot of empty cells, you can use sparse classes, and then you save a lot of processing time and storage. So, but this is dense data, so I've used dense vector. So I have then in my matrix a list of labeled points where the outcome is the first parameter and all the remaining data is a vector. Did that answer your question? Okay. Other questions? Okay, so good. Yeah? No? Okay. So that was the MLlib part, and now it's time for you to work a bit. So you have a lot of code examples, and I promise you, you have to solve the next challenge. You have all the code necessary covered in this tutorial. So this brings us to this one. Since the title was on DevOps, I at least wanted to introduce one DevOps related thing, and that's obtaining some metrics on HTTP server access log. So I've prepared this for you on this link, and you should now know how to upload access log to the Swift storage. I've just done that, but if you don't remember, you can just ask me. I will show it to you. And what you have learned so far. So this is an access log containing for each request a couple of features, and one is the the HTTP return code. So in most of the cases it's 200, but in some of the cases it's 404 or 401 or 500 or something, and especially the 500 codes are interesting for DevOps, because if you are using Spark streaming, you can in real time make out which URLs in your application are currently returning error. Yeah, and basically it's nothing else than a bit of pre-processing, and then it's nothing else than a word count, basically, because you do the pre-processing, you extract the status codes, and then you do a word count where the status code is the word. And when you have the data, you can even plot it to a bar chart, and I've also shown you that code. And this is also in the tutorial, the code for plotting a bar chart. Okay, so anybody interested in trying to solve that challenge? You want me to show it to you? Huh?
I was going to say, show us.
Okay. So I think you are all tired. It's already 5 o'clock, no? But I think I'm the only one who flew in today morning, so maybe I'm a bit more tired than you. Yeah. So I first say thank you. The slide deck is available online at bit.ly IBM Velocity. That's the registration link for the free tier. And now I will show you how to do it from scratch. So I have a cheat sheet, but let's try to do as most as possible from scratch. I think that way you are at least learning the most possible. So what I will create now is a new, I have code ready for Scala and for Python, but Python is the only one currently allowing us to plot things, so I suggest to use Python. And on the other hand, I've shown you some live coding in Scala, and now I can show you some live coding in Python that you can grab the difference. So first of all, we have to upload the access log file to the Swift storage, which is somewhere in my 100 tabs. Is it here? Anyways, then I will just restart it and manage files. Maybe I've closed. It's there. Velocity 15, and I upload this access log file, which resides here. So that's some open public URL where I got this. It's not so big. It's a good idea basically to start with small data if you're doing big data, because your development round trip is much faster. So we have it here. I can also show it to you that you get an idea what we are working on. So that's a standard Apache access log. And we want only to extract the status code. So normally you would do that as a Unix admin using grep and AWK and sort and set and stuff. And that's really cool, but it's not running in parallel. It only runs on one core, even if you have a 69 core machine. You don't agree? You're shaking your head? No? Okay. So if you do it in Spark, it will run in parallel. So we can, first of all, analyze petabytes of access log data if you like, and we can use streaming functionality. And we could even use SQL to query against HTTP log. So it's quite fun. So what we see here, the thing, the terminator between the fields looks to be a space. And to make things easy, I just get rid of that double quote here. So I will start a new, so it's log, a new notebook, and I say Scala context.text file, Swift, it's velocity 15.spark / access underscore log. And just to see if it worked, I say log.count to get an idea how many values are in there. So the ramp up is a bit long because we have to get a free worker, so it's 1500 something lines, so it's not too big. And now we want to get rid of, we said, the double quotes, and then we want to split on space. So I say filter. And since we are here in Python and not in Scala, I have to use the lambda notation. Lambda. That actually is the same like creating an inline function with Scala using this notation here. No? So lambda string, and then colon instead of equal sign and arrow. And then I have to check whether it contains, no, I want to remove the double quotes, so it's replace this one by this one, and then I say what I say take 1 or take 10. So I will see if it works for the first 10 lines. Doesn't work. Okay, so thanks a lot. So okay, now you I should have get rid of this. Maybe I use my cheat sheet anyways, just to save some time. I even didn't remove it, so I removed it in the Scala version, huh? Okay, I didn't remove it. Okay, anyways, so then we just don't remove it. Otherwise, I have no to fix that stuff. What we now do is we do a split. So we do a split of a string. That's pure Python code now, and we use a split character, the space character. I don't have the feeling that this worked. Using my cheat sheet again. I'm also tired, sorry for that. A split, no? Shows a tab?
You put a space or a tab?
I put a space, and there it's also a space. Not quite sure. Let's do it. I did the filter. I'm a complete idiot. See, I have to do a map, and then it works. No, you see that's array of arrays now. That's okay. That's what we expected, and I want to access the status code, which is index 8. So I do another map, and now my lambda function takes an array A, and out of this array A, I'm taking the element number 8. So I have the status codes. And now I do a collect because I expect this to run, but it doesn't run. And it doesn't run because my access log files is crappy. So there is some index out of bound exception. No, in Python it's called different, but it's an index out of bound exception. So there are some lines which are not sticking to the correct format. So what I do now is I will just drop these. And in Scala, it's really handy. In Scala, there is a class called try. And that's really fun because you can just surround any expression with try. And what it returns you is an object where you have a isSuccess method and a get method. And then you can just filter on the success elements. So you get rid of all elements which raised an exception. And then you just get. And that's not possible in Python. At least I've asked that question on Stack Overflow a couple of days before, and I didn't get a useful answer so far. But so I still have hope, but I don't think it's possible in Python. So what I have to do in Python is I have to actually create such a helper function, and that's this one. So that's a function taking an array. I will access element 8, and in case this raises an exception, I return the string error. So what I can do here is I say wrap exception, and then it either will contain the status code or error. So there's some, that's actually a bug in the Jupyter notebook that it suppresses always a bracket. So I hope this is fixed one day. So that's not the latest version of Jupyter. There's a newer version, but soon we will have that. So what happened here is wrap exception. Okay, let's copy paste. That's more safe even if you're a bit tired. So what happened here? List index out of range. I have to double check. Thank you. What would I do without you? So thanks a lot. Now it works. See? So now we have all the status code extracted, and now we want to do aggregation, and I've told you just use the word count example, but here we will do it again. So we do another map because we have to transform this list of status codes into a list of tuples. So we say lambda status code is something like that. And then we will get this one. And the cool thing now is we can use the reduce function, because the reduce function, the reduce by key function, will expect to get a list of tuples, and it expects that the first element of the tuple is the key. That means it will create partitions out of that data and partition together all the tuples with the same key, so that means the same status code, and then does what we tell it to do with the value of the tuple, and we will do just addition. So that means, just trying to get that right, is reduce by key. So my programs are always like a huge spaghetti, sorry for that, but reduce by key, and then the lambda function takes the takes a function where the accumulator is the first element and the second is the value, and then we say accu plus value, and then we should get a pretty decent result. Or an error. Okay, 1 second. I have to change this to this. Okay, you see here? Oh, we haven't get rid of the error, so we have to filter here, filter lambda s equals error, and it should not equal error. So invalid syntax. Again, this notebook bug is okay. Back to my cheat sheet. Yeah, I think I did it. Sorry, that's Scala syntax. So I have to use Python syntax. Is that Python? Yeah, so that should work. But you see, it's really similar as Python and Scala. So now you have that, and that's now an array of tuples, and that you can use to plot. And since I'm too tired to type this all by hand, I will just copy paste this and will show you what it's doing. So we have to store this as a result, and this result now is not a RDD anymore, because we are calling collect and take and so on. They are returning arrays and lists back to the driver, and in the language specific type, and in this case it's a list of tuples, and we will store this list of tuples in the result variable, and then we will use this result variable to do some pre-processing, blah blah blah. We will plot a bar chart, and I have to add some command before that, otherwise it doesn't work. That's this one. I still haven't figured out what it does. I have to Google for that, but it's necessary. So let's do that, and then let's run. And what's wrong here? I didn't do the imports. So NP stands for NumPy. That's a linear algebra extension for Python, which I of course have to import. And I have to import PLT, because PLT is standing for pyplot. So, and now it should run. So some warning there, but we ignore that. But now you see we have plotted a bar chart with a distribution of the HTTP status return codes. So there's a lot of 200 as expected, and yeah. So this was pretty fast because I did it for you. So I saved 15 minutes of your life, or we have 15 minutes of QA. Any questions to anything I've told you today? Yeah? Yeah, the code you have written scales to petabytes. And there are... Otherwise, we just could use plain Python, plain shell script, plain Scala, Java. But in this case, if you're using that functional programming piping thing, then it's parallel code.
Is that said that this course will be Java will be too long? Have you ever seen the Java 8?
No, I was expecting that question, but I haven't prepared for that. So I don't know how the lambda function on Java 8 works. Maybe it's better. but it's currently not in the tutorials. If you go to tutorials, that's the cool thing. You can switch on the examples in the Spark tutorials from Scala, Python, and Java with a tab, and then maybe I can just show it to you. It's really, really weird. Spark examples. Here you can switch, and let's take something more complicated. You see Java, actually you have to create functions as objects based on Spark function classes and pass them. And that's of course not that what Java 8 provides. So maybe in Java 8 it will be a bit more nice to use Java and Spark. Yeah. Let's see what happens. Yes?
What would be the reason for you to still use instead of
Maybe in an enterprise context where you have a running Hadoop cluster and it would be too much effort to upgrade it to Spark, or you have existing applications which are running on MapReduce and you can't use Spark. Because if you have an abstraction layer already on top of MapReduce, you might not get the best performance, but it solves the job for you as well. But from scratch project, I would go for Spark and even try Spark SQL, because I see the problem is to find people who can do that functional programming in Python and Scala, but you will easily find people capable of doing SQL. So if you can go to the point or reach the point where you offer somebody a SQL JDBC connection, which is possible with Scala, then the people are in, or they can just issue SQL queries against your data. No more questions? No? Okay. So thanks for joining those 2 sessions. I think it was really a lot of material which we covered. And I hope you will start using Spark in your day-to-day life and do something useful and funny with it. Thanks a lot.